Milton Glaser, premier designer, artist, and acting chairman of the board of directors of the School of Visual Arts, will introduce this year's commencement speaker, Dr. Gerald M. Edelman. Milton.
Fellow students, I was pleased to discover that Dr. Gerald Edelman and I were born within 1 week of another in New York City in 1929. I'm the older by a very slight margin. I was enthusiastic, hoping that our astrological forecasts were identical, and I shared some of his characteristics. Jerry, a longtime friend, is the smartest person I ever met. Knowing someone who's won a Nobel Prize is impressive, but winning 2 Nobel Prizes is absurd. But that is one of his many characteristics and accomplishments. Perhaps most significantly, he's the director of the Neurosciences Institute and president of the Neurosciences Research Foundation, and the author of many books, including The Remembered Present, Bright Air, Brilliant Fire with Giulio Toroni, A Universe of Consciousness, How Matter Becomes Imagination, and most recently, Wider Than the Sky, The Phenomenal Gift of Consciousness. In addition, he's the author of 500 research publications and the recipient of too many awards and honors to mention. His work on the most interesting subject in history, the brain, has produced a new model of human intelligence and has transformed our understanding of the world. Listen carefully. The ideas will move fast. I'm honored to introduce Dr. Gerald Edelman.
Thank you, Milton. President Rhodes, members of the board, members of the faculty, graduands, family, and friends. That extended salutation is often accompanied on these rites of passage by words of inspiration, exhortation, and congratulation. I hope you will take those as given, because I intend to deviate from the formula and discuss certain things that may be a bit arcane, if not too complicated. But bear with me. When you come to the hard parts, please hum them. I shall, in fact, try to discuss something that is not common for an empirical scientist, which is the whole subject of the mind. The mind is very rarely discussed among scientists, but not amongst philosophers and poets, as you'll see from this first presentation. This is a fragment from Marianne Moore, the great American poet. The mind is an enchanting thing, is an enchanted thing like the glaze on a katydid wing, subdivided by sun till the nettings are legion, like Giza King playing Scarlatti. And you might look in there and see the little hint of neuroanatomy and network in that subdivided netting. There it is. Now, in fact, the mind was removed from nature by the very beginnings of modern Western science. First by Galileo Galilei, certainly the founder of modern physics, who in his book, The Essayer, says, I know that without animals there would be no green and no warm, but that's not my concern. In fact, what he was interested in was what we call inertia. Somewhat later, René Descartes, in a search for certainty, proposed that in fact there were 2 categories of things. Res extensa, extended things that could be covered by physics, and res cogitans, which you have only to yourself, is a kind of spooky universe, which gives rise, of course, to the philosophy called dualism. With all due respect to the genius of the founder of modern philosophy, I have to say I believe that position is wrong. I'm going to take the naturalistic position, no spookiness involved. Now, in fact, what I would like to do is show you that we mustn't, because I take that physical position, assume that there's some ultimate reality that we can describe. For example, look at this. This is the lady in the vase illusion, which you can choose corrigibly to pick between the face and the vase. But look above there at this illusory contour of Gaetano Canizza, where you don't really have a choice. It's incorrigible. Anyone who doesn't see that overlying triangle, please raise your hand. I want you to come to California and study your brain. In fact, a physicist who has the conceit that he describes reality would go across one of those borders that you see so straight and see no change in energy, because there isn't any there. Your brain is constructing according to the context. This is an important thing to remember when you try to reduce too much. I'll come back to that. But in fact, we do have to say this, that science is attempting to get as close an account as possible. And I want to say that when I was 40 years old or so, when I first met Milton, I believe, I was a reductionist. I believed that everything could be accounted for by the collision of molecules. Mind you what I just said, everything could be accounted for by the collision of molecules and by quantum mechanics. I no longer believe that. In any case, I was visited in the early 80s by Andy Warhol, who came to me and he said in a breathy voice, "Dr. Edelman, may I ask you a question?" I said, "Certainly." He said, "Why does science take so long?" And I said, "Well, Mr. Warhol, when you do a Marilyn Monroe, does it have to be just the way it is?" He said, "Oh, no." He said, "I have something called a factory. We turn out silk screens. I'm not even there sometimes." I said, well, in science, it has to be just the way she is." And he says, "That's horrible." Let me now turn to a little disquisition on the nervous system to give you a feeling. Of course, in this limited time, that's all it can be. But let's take a look at the so-called cortex, the cerebral cortex of the human brain, which has a series of functionally distinct areas, some for vision, some for hearing, some for touch. I'm not sure I'm going to be able to do this and hang on to this microphone, so watch out for the speaker. There we are, vision. Here we are, hearing. Here we are, touch, and somatosensory. There we have it. And in the front, the most important part of the brain, which has evolved in the human species, in the hominid line, to an extraordinary degree, coming from within 1 million or so, 2 million or so years, from 400 cubic centimeters to 1,400 cubic centimeters, and regulating these sensory modalities. So you must not assume in any way that they are unique and definitive for that particular sense, for example, of seeing. It's more to it than that, as you will see. So, in fact, what does connect them? Well, what connects them is called a neuron. I'm not going to go into detail about this, but I want to give you a feeling for the dimensionality of the problem we're addressing. This neuron, which is a complex cell, that's a cartoon, is connected to other neurons by that little thing that you see in the circle at the bottom, called a synapse, or a connection. Let me give you a feeling for the dimensionality of the problem. Certainly in this room, each one of you has at least 30 billion nerve cells or neurons in your cortex alone. It's not all of your brain. And it has 1 million billion connections. If you counted one connection per second, you would just finish counting them 32 million years later. Let that sink in. Because, in fact, there's something in your brain called white matter, which connects the various regions of the brain, these functionally segregated regions, in a myriad number of ways, much larger, in fact, than the numbers I just gave you. And it does it in terms sometimes of maps which are dynamic and shifting and never identical in any two individuals. Indeed, the whole structure is built in such a way that it can't be. So you can take solace, whatever your feelings, you can take solace in the fact that your brain is unique in the history of the universe. If that gives you solace, fine. Certainly, I feel good about it myself. Now, the important word here is variation. Just what I mean. Every single brain at the micro level of its circuits is in fact different from any other at this level, and therefore it is totally preposterous to call the brain a computer. I want to make that radical statement. It is not a computer. A computer is one of the products of its elementary operations. That's certainly true. But everything about the way the brain develops and the way it's used says it's not a computer. So if someone says that Big Blue beat the Russian chess champion playing chess, it was not playing chess, it was playing the history of chess, which is ours. So here we have, I think, a kind of metaphor instead of a computer. This is by the Douanier Rousseau. It's called Primeval Forest with Setting Sun. And I'd like you to think of the brain, if you need a visual metaphor, this way. Some of it is regular, some of it is symmetric, some of it is random, and never are any two of them the same. That's pretty important. Okay, well, I said I was not a reductionist, but I want to challenge any of you who remain reductionists by giving you a test, by telling you a story. And if you can do this story in terms of, how should I say, molecular collisions or quantum mechanics, if you're that versed, I'd be very grateful. I want to meet you too, and study your brain. Because in fact, the story goes as follows. A young man in the heat of July suspects that his girl is carrying on with someone else. So he goes back to their apartment, searches under the bed, looks in the closet. She shrieks, says, "Nobody, you fool," denies everything. He finds himself at the rear window, trembling with rage, and he looks out of the corner of his eye and he sees on the fire escape below a chap wiping his brow and loosening his tie. He has a fit of anger, grabs a refrigerator, pokes it through the window, and drops it on this man's head, at which point he drops dead. The scene switches to heaven. 3 souls are being admitted, and St. Peter says, "You have to say how you died." The first one said, "Well, I thought there was some hanky-panky." She said, "No, but I finally saw this guy. I must have had an adrenaline fit. I grabbed this huge refrigerator, dropped it on his head, and must have dropped dead of a heart attack." The second guy said, "Well, you know, I couldn't afford an air conditioner, so I came early home from work. I had a drink. I stepped outside. I loosened my collar, wiped my brow, and this refrigerator fell on my head." And the third guy said, "I don't know. I was just sitting in this refrigerator, minding my own business." Having said so much, I now come to the hard part. But the hard part is to pay tribute to the greatest biologist and greatest biological theorist of all times, Charles Darwin, whose theory of natural selection is the very fiber of biological science. And it is really a remarkable theory. It simply says the following, that if I have a population of creatures, never mind whether animal or plant, and they're each one individual in some way, now we know that way is because of mutation and genetic change, and under threat of competition, either from other species or the environment, which it did not know, some individuals are fitter and survive to make progeny, others die off. And so natural selection is in fact differential amplification or differential reproduction. When I say natural selection, I think differential reproduction. And that's how we descended from hominid lines. Now, the interesting thing to me, and the clue to what I'd like to try as an hypothesis on you, is this, that in fact, evolution, when it could not deal with situations of the kind I just mentioned, but say with the inventions of organic chemistry where some molecule is formed that never existed before, there is something called your immune system, which can recognize that molecule notwithstanding. And the reason it does it is it uses population thinking of the kind Darwin did inside your own life, not in the millennia of evolution. So let's talk about the immune system and introduce you to a molecule that I spent 20 years of my life on, called the antibody molecule, as an example of selection, because I think it's easier that way. Look at this T or Y-shaped structure, and look at the yellow part, and then look at the blue part at the ends. Those are the parts that bind foreign molecules on bacteria, on viruses, and what have you. But that doesn't instruct the system to recognize